Hello everyone. Okay, let's continue and finish up our Live2D characters by implementing the override functions to give them the functionality that all of our character types should have, such as revealing, hiding, setting our colors, highlighting, and so on and so forth. So we're going to go ahead and take care of all of that in this episode, and then we'll move on to the last character type, which will be our 3D models, and we'll move on from there. So let's go ahead and get started on this by jumping into our Live2D character script and implementing the functions that are currently missing. So first thing is going to be setting the visibility of our characters. When setting the visibility through the variable, we can see that Stella indeed responds, but our Live2D character does not, because we need to change how that functions. To do that, let's go ahead and override it up here. So we'll go ahead and say public override, followed by our boolean is visible, and let's go ahead and define what we're looking for down here, separating get and set into the two different lines here. So if we're getting the value, then we want to check if we're revealing, or we want to check our render controller, and check the opacity and see if that is 1. If either of those are true, then our character is visible. If we're setting it, then let's go ahead and say render controller.opacity equals value. So if we're setting it to true, then the opacity will be 1, otherwise it will be false. And if we play this in Unity, yep, we can see they both respond now. If instead we tried to do this through the functions of hide and show, then we see Stella responds, but our Live2D character does not. So let's override the IEnumerator responsible for that. If you remember, that coroutine is showing or hiding, which is called from either the show or hide commands and runs the logic to reveal the character on screen. So if we jump into our Live2D character, to implement that is pretty simple. Let's just make the override IEnumerator, showing or hiding. And inside of here, we need to get the target alpha, depending on if we're trying to show or hide. So let's make a float for that called target alpha, and set that equal to, if we are showing, we'll set it to 1. If we are not, then we'll set it to 0. And now, while our alpha or our opacity is not equal to that, let's go ahead and move it towards that alpha. And we'll do that by checking render controller.opacity. So if our opacity is not equal to alpha, then we need to go ahead and loop and move ourselves towards that value. Our speed is going to be a value that we'll define up top here by making ourselves a public constant float default transition speed and setting that equal to 3. So we'll say default transition speed times time.delta time. Once we finish, we can go ahead and say co revealing equals null and co.hiding equals null as well. And with that in place, our characters will fade out and fade in. The next thing we're going to do is set the color of our characters. So if we try to set them both to red and then to white, color is only working on our sprite characters. So let's get it working on our Live2D characters as well. In our Live2D character, let's go ahead and override the function called setColor. And in this function, what we're going to do is, first of all, we're going to make sure that we call base.setColor. That way we can apply the actual color to this character's data. That won't actually apply the color to screen, so to do that, we need to go through each renderer in our render controller and set the color manually there. So we'll do a simple for each loop and say cubism renderer, and just call it a renderer in render controller dot renderers. And for each one of these, what we want to do is say renderer.color equals color. There we go. Now let's make it where we can transition the color by overriding the changing color IEnumerator. Now we have two functions that we need to make or override. That is our change color and also highlight. Highlight and change color are both going to operate on the color of these cubism renderers, so we're going to have them both reference the same sub-IEnumerator. That way we only have to write the logic once. So inside of this sub-IEnumerator, I'm just going to call it, make it private first of all, make IEnumerator, and then call this changing color L2D for Live2D. And we'll just take in a color for the target color and a float for the speed. And so when we change the color, let's go ahead and yield return for the duration of that IEnumerator that we just made. And once we finish there, say co.changingColor equals null. So what's going to go inside of here is going to be the actual logic to run on each of these cubism renderers. So the first thing we're going to do is we're going to cache all of the renderers inside of an array. So we can do that by defining a new cubism renderer array and calling it renderers and setting that equal to our render controller renderers. And now let's grab the start color from the renderer inside of this, the very first one. That way we know which color we're starting from, so we'll have our source and our target color. So color, start color equals this is one of the days where I cannot seem to type. And now we're going to use lerp to move all of these renderers to their target color. So since we're going to be using lerp, we'll need to keep track of the percentage through this loop, and we'll do that just by defining a new percent. And now let's go until this is finished. So while color percent is not equal to 1, then let's run the logic. So we'll say color percent plus equals our default transition speed times our speed times the time dot delta time. And so we don't have to perform this on every single renderer. Let's go ahead and cache this into a color value and then just apply it to all of the renderers. So color current color equals color dot lerp, and we will transition from the start color to the target color by the color percent. And now we can go ahead and loop through each one of these. So I'll copy from set color, since I'm having such a hard time typing today, and say renderer.color equals current color. And you know, there's a chance that color percent can actually go right above 1, so we could clamp color percent, and as a matter of fact, that's what I'm going to do. I'm going to go ahead and clamp color percent by saying equals mathf.clamp 01, and we will clamp the color percent plus all of that. That way it's not going to go above 1, and we'll go ahead and end it once it reaches the end there. So after we run all of that, let's go ahead and yield return null. And that should be the logic that'll run for changing the color on our Live2D character parts. To see this in action, we can change set color to transition color, and then see how all of this runs together. And we can see, yep, they transition their colors and then go back just the way they should. And now let's go ahead and try highlighting and unhighlighting these characters. First, we'll go ahead and unhighlight Stella, and then we'll go ahead and highlight Rice, and then we'll flip it around. And of course, we can see it doesn't work for Live2D, so let's fix that now. Since we've already got the logic in place for changing colors, this is going to be really quick. All we have to do is override the highlighting function for the character. So we'll make another public override and call this highlighting, which takes the Boolean and a speed multiplier. We'll remove all of this, and let's go ahead and find the target color for this character. Our target color that we want to move to is just going to be our display color, which, if we look at that, that is just simply seeing if we're highlighted, then it'll take the highlighted color, or it'll take the unhighlighted color, which will be just slightly darker. So that's the target color that we're going to be moving towards, and then we'll go ahead and yield return changing color L2D, just like we did for changing the color above. we'll move to the target color, and we'll move by the speed that we're trying to go at. And then CO highlighting equals null to cancel out the coroutine. Okay, there we go, and now we can see that they both highlight and unhighlight, and we can see that Rice is slightly darker because she is unhighlighted now. The next thing that we want to do is we want to make sure that our characters can change the direction that they're facing. So we'll start facing right, and then we'll flip and face left. Stella goes ahead and takes care of that, but our Live2D character is not doing anything, and we need to make sure that we do similarly to how the sprite character runs, which is duplicating its layers to fade it out, so that way we fade out the old and fade in the new. We want to do the same thing for Live2D character, but this process is going to be a little different, so let me go ahead and talk about that. So we want to make sure that the old version of our Live2D character, the old facing direction, fades out and we fade in the new one. So we could go through, like we did for the character, and create a duplicate of the layers and then just fade those out and fade in the new layers. But we've got a lot going on with our Live2D characters, a lot more than just still images. We've got animators, we've got different controllers and things that are running on this in real time, and if we just go ahead and duplicate, like, say, the parts of this thing, so we can fade in new ones facing a different direction, like, for instance, the old ones that we duplicate, they're going to stop running their animations, so they're kind of going to freeze, but I'd like for us to continue that and make it as smooth as possible, as smooth of a transition as we can, less of anything to like catch your eye and just know that something's wrong. So instead of duplicating the layers, we're going to go ahead and duplicate the entire Live2D character, animator, and all components included. So let's go ahead and make the override, which is just the function called face direction for our characters. So we'll say public override face direction, and this is how we're going to do this. We're going to start off by creating a new character controller, which is just the Live2D character. And let's make a separate function for that to keep the code isolated. So we'll make this private first of all. Private void create new character controller. And what we're going to do in here is we need to keep track of the old renderer. That way we can fade out however many old renderers we have and just fade in the new current render controller. So let's go up to the top and make ourselves a new private list to contain all the old renderers. And the renderers are simply going to be the Cubism render controller components. And we'll call that old renderers. And set that equal to a new list, which we will populate whenever we create a new character controller. So when we do create a new character controller, let's first cache the current one that we have. So old renderers.add render controller. And now let's create the new one. So game object new Live2D character equals object.instantiate, and we're going to instantiate not old renderers, but the render controller dot game object. And then we'll go ahead and parent that to the render controller dot transform dot parent, which would be the root animator for this character. So that would give us the new Live2D character, and let's go ahead and make sure that it's named the same thing inside of the inspector. Otherwise, it's going to be called our character and have some clones appended at the end of it. So new Live2D character dot name equals name, just like that. And now let's go ahead and reassign the components that we need to keep track of on this Live2D character to the ones that belong to this new instantiated character. And that would be our render controller, our expression controller, and our animator. So render controller equals new Live2D character dot get component Cubism render controller. And then the expression controller equals new Live2D character dot get component Cubism expression controller. And then the motion animator equals new Live2D character dot get component animator. Okay, and let's make this actually return the character that we've just created by changing void to GameObject, and then we'll simply return new Live2D character, and we can go ahead and start editing it here. So now let's go ahead and create it whenever we face a new direction. So GameObject new Live2D character equals create, if I could spell that right, create new character controller. And now let's go ahead and make sure that our local scale for this new controller is either positive or negative depending on which direction that we want to face. If we look back at our character layers, whenever we flip the character, it's going to check and see if we're facing left or not. If we're facing left, then we're just going to stick with the value of 1, because if you look back at character, our default orientation is set to left, wherever that is, right here. Default orientation is left. So we could go ahead and, since I know it's going to be left for all of my characters, basically, I'm just going ahead and defaulting this to +1 if we're facing left, because that means we don't have to change anything. But if we face right, then we need to change our scale to negative. That way it'll face the opposite direction. So for our Live2D character, let's go ahead and take care of that. Let's say new Live2D character.transform.local scale equals new vector 3. All right, and so we're going to have some kind of value for x here. And our y is just going to be unchanged. So new Live2D character.transform.local scale.y, and then new Live2D character. Get back over there. .transform.local scale.z. So our x scale is going to go right here, but for our Live2D characters, as opposed to like the sprite characters or what have you, we did scale up our character because if it's set on 1, it's just way too small. Since I didn't make a root for that, I'm going to want to reference whatever the scale is for the actual Live2D character here instead of 1 or -1, which is why we're defining the new vector 3 like this. So let's actually go ahead and cache the x scale whenever our character is created. That way we know about how big they are, and it'll just make things a little easier. So private float x scale will be the width of the character. And whenever we create the new character, we'll say that x scale equals render controller.transform.local scale.x. And now back down here, let's go ahead and check if we're facing left. If we are, it's going to be x scale. If it's not, if we're not facing left, then it's going to be negative x scale. So we'll flip the character to face the right. All right, so we have our new Live2D character images fading in, or at this point they're actually going to be the same transparency as the old one. So let's make sure that this new Live2D character is fully transparent by saying render controller dot opacity equals 0. And this render controller will of course belong to the one that we just created. So now we'll be able to fade that one in. And let's go ahead and cache our transition speed for how fast this fade in should be for the new layer by saying float transition speed equals default transition speed times speed multiplier times time.delta time. And now we want to loop through until our main renderer is fully opaque and all of our old renderers are just out and they're gone. So let's say while render controller dot opacity is less than 1, or old renderers dot any. And for us to use any, we do need to use the system.link namespace. So using system.link. Now let's go back down here. Say old renderers any, we'll just call each renderer R, and check if r.opacity is greater than 0. So we roll through until all of our old renderers are fully faded out. So first thing let's do is let's fade in our new renderer. So let's say render controller dot opacity equals mathf dot move towards, and we're going to move our render controller dot opacity towards 1, and we're going to move it by the transition speed. And then for each cubism render controller for old renderer in old renderers, we're going to go ahead and say that renderer, or we're going to say that old renderer dot opacity equals mathf dot move towards old renderer, move it towards 0 by the transition speed. Or not old renderer, but old renderer dot opacity. And then just yield return null. Once we're done with that, then we'll go ahead and destroy all of the old renderers. That way they're out of the scene. So we'll do that by saying for each cubism render controller R in old renderers, say object dot destroy r dot game object, and then old renderers dot clear the list, and say co flipping equals null, and go ahead and end off the coroutine right there. So if we check this out in Unity now, they both flip from right to left. Rice looked a little strange there. Looked like she changed her position too. If we go ahead and look at Rice, oh yeah, she's got this invisible part to her there. So it's working off of the pivot translation there. So if I just set that to negative real quick, yeah, we see this. The center of her is actually between her body and this little cannon there. If you wanted to change that, then what you could do instead of flipping the scale of the actual Live2D character here, what you could do is make a child of anim, which then Rice, or the Live2D character, is parented to that child. You can position that child right and directly in the center of the character here, and then just flip that from left to right instead. So she won't be flipping off of the pivot of this whole image section here, but simply off of whatever pivot point that you assign based off of that parent object. And now the next big thing that we have to do is take care of the priority sorting. So if we have all of these sprite characters, and then we create them, set them in their positions, and then sort them in this order, kind of random, and then at the very end make sure that Stella is set as the top priority and she's above all the other characters, then what we wind up is something like this. They're created, they're sorted, and then Stella comes up in front. We need to be able to do the same thing for our Live2D characters. Now the logic for setting the priorities is running separately from the character classes themselves, so we could technically try to run this with our Live2D characters and see what happens. They pop up on screen. We can see that they're sorted over here in this list, so the hierarchy sorting is working, but of course the sorting on screen is not working because Live2D characters are not hierarchy based, they are depth based. So we need to change this up to look at the character type and make the right call there. But instead of overriding this and just changing how this sorting method works on the character manager, maybe we can still use this to our advantage by still sorting them in the hierarchy and then using their index in the hierarchy to control the sorting depth in which they appear on screen. To do this, if we look in our character manager, we can leave the sort characters functions alone, and all of the logic is fine. It all points down to this one sort characters function, which then sets the sibling index of each one of these characters. And from this point, we can then call a separate function on the character, which will perform a different type of logic depending on the character type to set its depth on the screen. So for sprite characters, it won't need to do this, but for Live2D characters and 3D characters, it definitely will. So what we can do is come into the character class, move all the way down to the bottom, and make ourselves a new public virtual void and call it onSort, and pass in an int for the sorting index. And by default, it's going to do nothing because this is a base character type. and that means our sprite character will not inherit, it will not change that at all, but our Live2D character will. So on Live2D character, let's go ahead and say public override on sort. And what happens when we receive this function that the character has been sorted? We can then come in and say render controller dot sorting order equals our sorting index multiplied by some kind of value. In the previous video, we established that about 250 was a good depth for the characters. This might change depending on your use case. It might be more, it might be less. So you want to find that sweet number by just stacking characters on top of each other and changing the sorting order, which again is inside of our Live2D characters here. Let me just pull up one here. Let's pull up Mao and just enable her on the screen. If we look at the render controller under sorting, order, and layer, this is what we're talking about. This is the sorting order. So you want to change this number and see at what point they start stacking on each other appropriately. Once you find that number, we can come to the top of our Live2D character script and make another constant called public constant integer, and this will be the character sorting depth. And then maybe I'll add size to the end of that. So character sorting depth size will be 250 per character. So once we receive this sorting order, we'll get the index and we'll multiply by that by our sorting as quickly as I made it. I already forgot what I called it. Character sorting depth size. So we multiply it, and then that should go ahead and stack the characters the right way. So in Character Manager, after we set the sibling index, let's now say character.onSort and pass in the integer that has been assigned to them. So with that logic in place, let's go ahead and run this again and see if that works. It's starting up. There we go, our characters sort, and then rice comes to the front. Perfect. So that actually works very well, and we didn't even have to change the sorting logic for our character manager. So that's great. Rolling through our character base class here and looking at all these functions, there aren't any other overrides that we need to worry about. And if we come to character Live2D and just say public override and get the list of what's available, it's just hide and show, set position, move position, but all of those are fine just as they are. So that's actually all the functions that we need to override to give our Live2D characters their complete capabilities for this whole character system. We may add some more as time goes on, or you may add your own, but for now, that is all that we need to worry about to get equality between our sprite characters and our Live2D characters. So that is it. There's nothing more for us to do here, so I'm going to end this off now, and next week we're going to work on introducing our 3D characters and start getting those guys on screen as our final character type. So look forward to dishing that out for you guys, and until then, I hope you have a wonderful week. Bye.